Hello, and we're back, and this is episode 2. And what we're going to do is we're going to make this faster. So rather than going through the items that I did in my book, in my original order, we're just going to go with Design Roulette. So, where she stops, nobody knows. We're going to ask Mo, give me a number from 1 to 10.
7.
7, okay. Make sure I've got my button ready to go. As you may have already noticed, we've added the annunciation of the mouse buttons and the key presses down in the bottom of the screen for you. We can now see as we go. I use a lot of shortcut keys. Alright, here we go. Countdown 7, 6, 5, 4, 3, 2, 1. Stop it! Oh yay! Special bearing! Don't we love special bearing? Everybody loves special bearing. It's great. So these are all. It's not actually. You'll see. It's actually fairly simplistic or straightforward. But all of these are from my old drafting book. I'll put a link in the description to the new edition of it. Special bearing. This one is actually shown in a bit of a cross section, in what they would call a quarter section. What it allows us to do is actually just run everything off of the center line. So the first thing we want to do is we want to, of course, save our drawing. Now we actually have some names, and this is
bearing.
And it is going to start, as all of them do, pretty much with a sketch. But I'm going to basically try and duplicate this profile here on this plane, and then just revolve it all the way around, as if it were to be magically revolved like a piece of pottery.
That's cool.
So we'll go to our top view, and we're going to start with a construction line down the middle. You'll see it likes to snap to certain positions, like 90 degrees. So this will be our center line. And to begin with, we want that center line to be a construction line so it doesn't interfere with anything and is there just to be a reference. So that's essentially this line here, right through the middle of the object. And we can extend it down below, but we don't have to, since this line as a reference can be all the way across. This being our center line, being this line here, and we're going to go ahead and make this horizontal line this line here on the bearing, which is kind of what it's showing here. We'll add another line that we can use for offset measurements. And again, make that a construction line. And then we can start doing our various offsets from the center. So this first borehole actually has this dimension to it, which is a little hard to read. 1.438 ream to 1.436, so within 2/10,000ths of an inch. So we're actually going to work from the outside in instead, since we know the outer diameter shown here as 5.12 all the way out to this outer edge. So that's our first offset. And that's just this tool here. We want to offset that. I'm not going to chain selection as if it's doing like a circle, or not a circle, but a series of lines that make an outline. And this is going to be, first off, let's not be doing everything in metric when all the dimensions given are in inches. There we go. Change over to inches. There we go. Now back to our offset. We're going to offset this. It's going to be offset at 5.12. That's a diameter. And since we're doing half of that, that's a radius. And we could do the math in our head and we'd probably get it wrong. So we're going to say 5.12 divided by 2. And that helps us just put it in without having to do our own math. I should know.
6.
5.12, half of 512 would be 256. That should be something really right off the top of my head, but it's a very convenient thing that you can just put in formulas into your dimensions. So the next offset for this inner line is 4.76. So we're going to right click, repeat offset, select the object again, 4.76 over 2. Then our next number is this little notch here, which is shown in this dimension as 0.2 of an inch. So in our world, that's this current dimension, 2.38, which is the inside of that notch, minus 0.2. So that gives us the width of the notch. So again, this is all going to be a bunch of offsets by and large. And our distance is going to be the 4.76 divided by 2 minus the 0.2 width of the notch. There's our next line. And that's our notch. And then finally we have this outer edge on the other side, which it shows a 2.06 diameter. So repeat the offset, 2.06 over 2. That's our inside dimension. So now that we have all of those lines designed as we need them, let's draw. This is our bottom line. Is across the bottom here, and it is from this innermost part to our notch. There it is. There's the line. So that line, and then let's zoom in a little. This line actually goes out to some distance forward. This line here being this inner edge. And let's see, it is, okay, they give us two dimensions. The overall dimension of 3 inches, and then this part here to 2 inches. And so to find this from here to here is this 2 inch minus this 0.62 inch. Right? So if we take this line that's 2 inches away from the edge and we separate it down to here, then, or move it down to here, that would be 2 inches minus this 0.62. And that'll give us this point right here on the object. So what we're going to do is do an offset from here of this line. Offset. And it's going to come out here a distance of 2 inches minus the 0.262. So 2 inches minus 0.62. Now, these lines don't line up, right? It actually needs to be further out. So what we can do is we can take this line and say it needs to be extended to the next line that it would intersect with. And we can do that with that and those. And we begin to get this edge right here. So we got that edge. Now that we have this front bit right here, which is this, we know there's going to be this back line that is 2 inches away from the front. So again with the offsets. Now, interestingly, it won't let you offset an offset line, but it will let you offset a line. That was the chain function where it picks all the lines that are connected. We didn't really need that. So this is going to be in the opposite direction, 2 inches. So now we're beginning to get our shape. We need to find out what's this depth right here. What's the depth of this notch? It is 0.18 or no, 0.12 rather. We can make this bigger. We don't have to keep staring at it like that. There we go, 0.12. That's the one. So it's a 0.12 of an inch from this line up. So let's do offset of this line, negative 0.12. The only reason it's negative is because it's above the center line versus below the center line. And then this line will actually extend across. And then we begin to see our shape. Here's this edge. There's this edge here. This little part before the notch, and then all of that. Now all we're really missing is this little tang pit right here. So we need to find out how far that is from the front edge. And let's see. Oh, that's the 2.06. So really now we need to put this line in here, which is the center bore. And the center bore, 1438 to 1.436, so the middle of that is 1.437. So we'll use that. 1.437. And again, over 2. Because it's radius versus a diameter. And then, let's see, we need this bottom line to extend. So if we extend that line, you see it highlights red where what it's about to do. And then we need this final top line here that is 3 inches from the bottom. Offset from that. We can drag it up if we want to. It's easier just to put in the numbers, really. And of course, again, we're going up, so we need to make it -3. Now we have most of our shape. We just have this extra area. So now we're going to go back in and trim so that the only lines we have are the lines that are involved in the actual design. And it is, that goes, and then we actually need to extend this guy across, and then trim that piece in the middle. If we expand our sketch palette, so we can hide some of these extra things like dimensions and constraints, we get a clearer view of our object. There's a few extraneous lines. I suppose we could trim that one out. This one here. And now this shape is, whoops, didn't mean to do that. So this shape that is shaded in blue is the shape shown here, right? Now we've got that shape. If we look at it from, there we go, the same kind of direction, you'll see it looks pretty much correct, right? We can do some little checks before we do the rounding off. So first off, let's finish up trimming it up. So this looks relatively narrower than this, correct? But we can do some things. First off, let me get my big body out the way, and we can start clicking on some lines. So that's a 2-inch line, and that's a 2-inch line, sure enough. This extra bit should be a 1-inch line for a total of 3. That's true. Well, let's roll it out and see what we get first, and then we will come back and we can edit the layout or the original drawing later, and you'll see one of the advantages of having this kind of parametric design. So if we just simply, well, first off we have to finish the sketch. We've got this profile highlighted. You can do a rotate, about this axis, and boom, there's your object. Well, almost the object, correct? There's a couple of things missing. First off, these little screw holes. Now, it's pretty convenient, easy to do in Fusion. We'll just drop a sketch right on that surface. It says the screw holes are at 3.12 inches from the center line. So 3.12 is the diameter. So again, 3.12 over 2. Now we have a length. Make sure it's at 90 degrees. Now we have a line that gives us a point. And the reason I do that is so that when we finish the sketch, we have that one endpoint that we can highlight and say, let's drill a hole. Now we got all these hole specifications. As you'll notice over here, we actually have some details about our hole. It's 3/8 of an inch drill with a 70-degree countersink to a 1/4 inch diameter. 3 holes, 3/4 inch diameter, I should say. So what that's saying, and this is showing in the little diagram here, we want a countersunk hole. We want the top diameter here to be 0.75 of an inch. We want the degrees to be 70. And the length I'm not too worried about because it's just going to actually go through the whole thing. We're not going to have this counter bore on the bottom. The inside diameter, which is 3/8 of an inch. So I don't have to worry about knowing what that is in decimal. We'll just put in 3 divided by 1/8 of an inch. Now we've got this hole, and it's already got all of the detail of the countersink. Correct? Now all we need to do is make the other 2. And conveniently, that's really easy to do. Once we have that feature, we can say we want to create a circular pattern, and we want that to be of features. We select the feature. It says you want to do a full circle. The axis is going to be this green axis in the middle.
I see 3 holes.
All right. So
Is it supposed to have 4 holes?
No, it's not. So the way this was drawn was in this quarter section where they took out the pie, 1/4 pie piece. Now, I haven't seen how to do that directly in Fusion, but you do have the ability to do what is called a section analysis, which allows you to say, put a cut section plane on this plane here, and you can see it actually shows that same profile. I don't know why it doesn't directly do a quarter section, but you can change the you can change the section analysis to be the other plane if you wanted to. And now it looks correct. See, it was just a distortion of the drawing, but when it's in this view, now it looks correctly proportional. I'll go home. You see what I'm saying? It didn't quite look correct when I was drawing it, but in here it does. There we go!
Yay!
Yay! And you know what? We got through it without a single
vertically composited patch amplers. Then pin slam fasten pan traps at both maiden apexes of the gym joints.
I promise no gym joints. Join us next time for the Retro Redo Design Roulette. We'll see you then.
I like it.